This is question number 34. Find a rational zero by graphing and use it to find all the other roots of this particular third degree polynomial. Okay, so we're going to do some little graphing to find our real root. We know that we're going to have an R1, we're going to have an R2, and we're going to have an R3 since this is third degree. And we're going to have to graph it to see the real root. So I'm going to take my calculator out, and we're going to type this function in the calculator, x to the third. We've got a plus 3x squared. Oh, try that again. X to the third plus 3x squared. I believe it was minus 4x, and then that last term was a minus 12. So I'll put minus 12 here. And you should be able to always see your roots in the standard window. And you can see that we've got actually all real roots, which is kind of nice. We don't have to do any longer synthetic division. So you'll notice you have a single root here, you have a single root here, and you have a single root here. So therefore, it should be very easy to identify the roots and to write factored form. So we've got a real root at -3, a real root at -2, and 2. So -3, -2, and 2. These are all reals, and they are all single roots. So if you wanted to, you could write this now in factored form. So here we go, factored form. Our final factored form. The a value is 1, the leading coefficient, 1x cubed, and we would have an x plus 3, and an x plus 2, and an x minus 2. After graphing that particular function, you can see that we had that root at -3, we had that root at -2, that root at +2, which means that in your factored form, all of those signs are going to flip to x plus 3, x plus 2, and x minus 2. And that is question 34 and the end of your review.